All right, I titled this one just More Properties of Triangles. We're just going to continue to talk about triangles and add some things that the other video, left out. So first, let's look at this triangle again. And I'm going to call these angles angle A, angle B, and angle C. Okay, we know that if you take angle A plus angle B plus angle C, angle C, what do we get? Well, we get 180 degrees, right? We actually called that the triangle sum theorem. Triangle sum theorem. We've been using that for a really long time in geometry. We probably did it, I don't know, man, a long time ago, like unit, maybe even at the end of unit 1. So we know that no matter what type of triangle it is, the sum of the three interior angles, meaning the angles of the triangles A, B, and C, equal 180 degrees. Okay, that's a fact. Now I'm going to take any of these bases, so I could do this, extend it that way, I could extend that, extend that, extend that, extend that. It doesn't really matter. I'm just going to extend this one. So I'm going to take this line and I'm going to extend it. And I'm going to look at this angle here, and I'm going to call that one of the exterior angles. Okay? And so I'm going to call that angle D. Okay, so we already know that for all triangles, A plus B plus C equals 180. But then we also know that if I extend that side, C and D are linear pairs, right? So then if I do angle D plus angle C, I also get 180 degrees because they're linear pairs. And we know that linear pairs are supplements, meaning they add up to 180 degrees. And so if you look at some algebra here, if A plus B plus C is 180, but D plus C is equal to 180, so this is some number, plus C equals 180, but that plus C equals 180, then can't we conclude that those two are the same? And that's what we got when we start talking about the exterior angle theorem. In this case, A plus B, angle A plus angle B, that's garbage. Angle A plus angle B does in fact equal angle D, and that is a new theorem that we've decided is called the exterior angle theorem. And it is exactly what it says right there. It says that the exterior angle is equal to the sum of the other two interior angles. Okay, so you could do, a lot of different problems with that if you needed to. So we could draw some triangle. We could label this 50 degrees, 65 degrees, and we could do this. And I already know that this angle has to equal the sum of those two angles. So this has to be 115. And I could do it in another way if I wanted to. If I wanted to go through the process, I could also just say, well, you know what? 50 and 65, that makes 115, but there's 180 degrees left in the triangle. So if that's 50 and that's 65, that's 115. That guy's got to also be 65. But if that's 65 and those two make a linear pair, then 65 plus what equals 180, and you'd get 115. You're like, oh my goodness, it's the same thing. Well, of course it's the same thing. Because using these two in combination is the exact same thing as using the exterior angle theorem. We know that the exterior angle equals those two sum. Or we could just find that guy and then use a linear pair to find that. Okay? So that we know that. And again, we can take any of the exterior angles. We could extend this side over here and look at that exterior angle. That exterior angle has to equal B plus C. We could look at extend that side. Extend that side. And look at that exterior angle. And that has to equal A plus C. Right? It doesn't really matter. We can do a variety of them. And that's usually the one we look at, but it doesn't matter. Okay, I got exterior angles. Not too bad, right? Okay, one more thing in this particular video, and let's look at mid-segments. Mid-segments. So, mid, meaning midpoint, and segments, meaning just kind of a line segment. So let's take some triangle. Okay, first, we gotta be able to find these mid-segments. The mid-segments are starting from the midpoint. So let's say that's the midpoint, that's the midpoint, and that's the midpoint, and we can find midpoint, right? Midpoint is the average, just as a reminder. Midpoint's the average point. It's also literally the middle. And if we wanted to find the midpoint xy's, it's just taking the x values and adding them up and dividing by 2, which is how you find the average x value, and then the y. All right, so we can find these midpoints. So algebraically, we can find the midpoints on a graph. We can count. We can do a variety of things. So let's pretend that those 3 red are indeed the midpoints, and then the mid-segments are the segments that connect the midpoints. So there's a mid-segment, there's a mid-segment, and there's a mid-segment. And there are 2 properties that are really cool about mid-segments. Let's focus on the 2 really dark ones. Let's focus on that thick red one and how it relates to its corresponding side. Okay? So I'm talking about that red mid-segment and that side. And if you just kind of look at it, you might be able to just figure out that the mid-segments have 2 interesting properties. Property 1 is that they're parallel. And what I mean by parallel, I mean they have the exact same slope, which is kind of cool. Meaning the rise and run of this guy and the rise and run of that guy are the same. And the second thing is that the mid-segment is half the size of the line. Meaning, algebraically, you could take 2 times the mid-segment equals the actual side itself. Okay? So for instance, if this whole thing was 16 from there to there, we know that this is the midpoint. Well, that means this is 8, and this is 8, and it also means that the mid-segment is 8. The mid-segment is half the size of the actual line. These are identical length segments, 8, 8, 8. Okay? Mid-segments are kind of cool. So there's that mid-segment, but then there's this mid-segment. This mid-segment is parallel to that guy and half of its size. This mid-segment, which will maybe make a dotted line, is parallel to this side and also half of its side. So if that guy is 10, we know that's 5, and that's 5, and that's 5, and we can do all sorts of stuff with mid-segments as well. Okay? So on this one, we kind of just focused on 2 things. We focused on kind of proving the exterior angle theorem, given the triangle sum and linear pair, and then we talked about mid-segments. Okay? And I think that's all I want to do on this particular video, and then we'll do some bisecting stuff on the next one.